To see the true scale of India, you have to zoom out. This diamond-shaped landmass is the seventh largest nation on Earth, a self-contained subcontinent. Within these borders, geography exists in sharp conflict. Traveling just a few hundred miles can be the difference between sub-zero, oxygen-thin altitudes and sun-bleached desert dunes where rainfall is a rarity. In the far north, you find high-altitude frozen biomes. These jagged, snow-capped peaks pierce the clouds and sustain temperatures that rarely rise above freezing. Yet move toward the western edge and the environment shifts. The ice is replaced by vast oceans of golden sand baking under a relentless sun. These environments didn't appear by chance. They are the result of a tectonic collision 71 million years ago, when the landmass of India was an island hurtling across the ocean. 50 million years ago, the isolated Indian plate, part of Gondwana, smashed directly into the Eurasian plate. The force of that impact caused the Earth's crust to crumple. The edges of both plates buckled and folded upward, much like a carpet being pushed against a wall. That crumpled rock became the Great Himalayas. They formed a 2,500-kilometer-long vertical wall of snow and rock that serves as a massive physical barrier. And the crash is still happening. Tectonic pressure continues to drive the plates together, meaning the Himalayas grow by about 5 millimeters every single year. By thrusting that stone wall into the sky, the collision changed the climate of the continent. The peaks act as a barricade, blocking freezing northern winds and trapping moisture over the land. High in those peaks, that trapped moisture froze into glaciers. As they melt, they feed the subcontinent's major rivers, the Ganga, the Indus, and the Brahmaputra. These rivers act as a massive delivery system. As they flow south, they scrape minerals directly off the Himalayan rock and spread that sediment across the flatlands. This created the Gangetic Plains. It is a vibrant green, highly fertile region that provides the agricultural base for the entire nation. Further south, the terrain changes. The peninsular plateau is built on ancient rock and elevated land, flanked by tropical mountain barriers known as the Ghats. The peninsula ends in 7,500 kilometers of coastline. Where the rivers reach the ocean, they form massive deltas, like the Sundarbans, home to dense, tangled mangrove systems. This geological cycle sustains life on a massive scale. The mountains capture the water, the rivers carry the minerals, and the resulting soil provides the food for over 1 billion people. But while the rivers created zones of abundance, the geological layout also carved out harsh margins. These are zones where the environment makes survival extremely difficult. In Ladakh, the land sits in a permanent freezing shadow, a high-altitude cold desert where isolated human settlements are dwarfed by the barren rock. To survive, people rely on the yak's specialized biology. Its incredibly thick, shaggy coat allows it to endure sub-zero temperatures, providing milk, wool, and transport. On the western edge of the country, the challenge is the opposite, the scorching heat of the Thar Desert. The desert is contained by the Aravalli Hills, a dark, jagged spine of rock that is 2.5 billion years old. These hills act as a physical wall, stopping the desert sands from spreading further east. In these hostile zones, survival requires more than just biology. It requires human ingenuity to overcome the limits of the land. In the Thar, fetching water is the primary labor of daily life. Women trek massive distances, carrying heavy metal pots to provide basic hydration. Because water is so scarce, locals have developed unique ways to preserve every drop, even using dry desert sand instead of water to scrub and clean their dishes. They also utilize ancient architectural technology to capture rare rainfall, building underground harvesting systems called tinkas and kunds. These systems are engineered to catch even the smallest amount of rain and store it safely underground, protected from evaporation. The 71-million-year-old tectonic crash that raised the highest peaks also created these punishing margins. From the high-altitude ice to the deep desert sand, the terrain of the subcontinent requires constant human ingenuity to make life possible.